In our previous video we saw that all substances or all matter is made up of mixtures and pure substances. So we're going to have a closer look at those right now. Mixtures, something that has a contaminant or a two or more different substances that are not chemically combined or bonded. Our pure substances are the things that we call elements from the periodic table. Remember the periodic table like this. We've got lithium, hydrogen, helium, and those substances up there. And compounds, which look like mixtures to start with, but the components of compounds are joined together. So we've got an element and an element, or different ratio of elements, and those are bonded together. Mixtures, they tend to be separate and they're not bonded together. Okay, so a compound is pure and an element is pure. So we're going to have a quick look at those in a moment. So when we look at a mixture, we know that it contains more than one type of particle. In other words, you can't have a mixture of something that's all the same particle. You need something else within that mixture. Its composition can vary. So a mixture, you could have a ratio, a different ratio. So not all, that's one mixture, and another mixture could be, and another mixture could be. So these are all different compositions, but they are the same mixture of triangles and circles. The other thing about a mixture, its properties can vary, and those properties will depend on things like the composition. Remember, properties are just attributes of a particular substance, such as melting point. It can have chemical properties or physical properties, boiling point, color, particle size, you know, a whole range of different things. But we say we looked at boiling point. If I have lots of these, it might have a certain boiling point, a certain degrees when it starts to boil, and in this case I have a different ratio of these elements, and it might affect the boiling point. It could have a lower boiling point, or it could have a higher boiling point. So in this case, these mixtures have different properties. Some examples of mixtures, we could have sand and sodium chloride. This is one that occurs commonly in nature. So we've got our sand, which is mainly silica oxide, but we also have other things in there, like shells and small rocks of other minerals, and we have a variety of other things, rutile and so a range of minerals. Okay, these are a mixture, they're not all chemically combined together. In this case, it's a mixture of a compound, it's a mixture of other compounds, rock. There might even be elements in there, maybe some gold is commonly found in small amounts in sand. But we also have our sodium chloride, so another compound made up of two elements. So this sand here is a mixture of compounds. Some other mixtures you might see, we've got rocks, In this case, we've got iodine, which is an element. In this case, it's dissolved in water. So we've got H2O, one compound. We've got some ions, came from an element, and they're mixed together. They're not chemically bonded, although there can be some attraction between ions and the water molecules. Another one that you might commonly see, such as in the kitchen or in the home, a mixture of spices, mixture of jelly beans. They're all jelly beans, but we have different varieties, different types. And so you can see there's a variety of mixtures around. They're contaminated. They don't contain only one type of substance. So in this case, we're looking now at pure substances, so things that are not mixtures. They don't have contaminants. If it's pure, if they have a contaminant there, then it's a mixture. So pure substances, and the examples that we see more often than not in chemistry come from the periodic table. And it contains a variety of elements, pure substances. And an example would be if you looked in a light outside a restaurant, you might have just neon gas in that light. You might have, in a jar of magnesium ribbon, you might just have magnesium. You could have a piece of aluminium, say from a windowsill, and it might be pure aluminium, if you're lucky. The wires that we use are often pure copper. Sometimes they have some impurities in them, so they're not pure. But copper atom, just copper on its own, is pure. An example of something that's might cause some confusion, if we looked at, say, common table salt, sodium chloride, is that pure? Well, are the parts bonded together? Yes. And they're held together with ionic bonds. So if we have a look at a piece of table salt, we'll look at iron oxide, another salt. The one that causes is actually rust. Now, this looks similar to sodium chloride, but in this case we can see we have a fixed ratio. It's 1 to 1. So we don't have extra iron, we don't have extra oxygen. They're stuck in a fixed ratio. It's a pure substance. It's not changing. It's only iron and oxygen, 1 to 1. Okay, if we had twice as much iron as oxygen, it would be a different ratio, but that would be a different substance. So this one here is a compound, and it's just iron oxide, and they're fixed ratio, so it is pure. Okay, we go to our last slide. We see that we have all matter. We have mixtures that have contamination, or two or more different substances not bonded together, separate. In pure substances, we have our elements from the periodic table. As long as they're not mixed together with other elements, if it's just pure, particular one element pure in a jar or container, then it's an element. Compounds, they have to be chemically bonded. There's a bond there between them. If it was just oxygen and just iron, then it could be any amount of iron and the oxygen would slowly react with it, but it has to be chemically bonded in order to form a compound. If we look now at an example here, and you can work out in this case, we have a jar that is a mixture of insects. So we've got scorpions, and we've got grasshoppers, and we've got beetles, and we've got dragonflies. We also have different types, so different colors of those objects. This one is a mixture, a complete mixture. There's nothing pure about it. There are different types of animals, and there are different types of colors. If we look at the next example, here we have something that's still a mixture. Even though they're all the same color, they're different varieties. We've got grasshoppers, we've got caterpillars, we've got scorpions, and we've got spiders. So it's still a mixture. And the last example here, we have a pure substance. There is only one type, and it's the butterfly. There's only one color, and it's the butterfly. So there's no other ones there. It happens to be an example of an element because they're not chemically joined together. They could be, but now it would be a molecule of that element. Okay, there's no compound, they're not different types chemically joined, they're separate and they're one type. So that's just some examples of an analogy looking at a variety of mixtures and pure compounds. A final example would be something like tap water. Okay, it comes out of a tap. It's a great tap. Okay, splashes out. It's a mixture. It has in it chlorine, fluorine. It has H2O, it has other things, some calcium, and a variety of other ions. So different substances all in this together. They might be dissolved, but they're mixed together, so it's a mixture. If it were pure water, so if we have a bottle of absolutely pure H2O, there's nothing else, it's just H and O and lots of them, lots of these compound molecules. Compound because there's two different types joined together, so they're compounds. There's no mixture, it's just pure water, one substance, one type of substance, one type of molecule, pure compound. So in fact it's so pure that it doesn't even conduct electricity under normal conditions, unless it's very, very high voltage, but these sort of ions are needed for this to be conductive. Okay, tap water, impure. Pure water, pure, as the name suggests.